Today, I am presenting Wiring a City, a socio-technical perspective on deploying urban sensor networks. This project was completed by an interdisciplinary team with collaborators from computer science, information science, and environmental design at the University of Colorado Boulder. Urban areas around the world are struggling with the overlapping challenges of rapid growth in population and increasing natural disasters due to climate change. Local governments are experimenting with novel sensing technologies, often called smart city technologies, to address these and other challenges. Previous work in the technical literature has characterized the ideal smart city infrastructure as a system of systems in which the four phases of data collection, management, analysis, and impacts are part of a connected closed-loop system which is automated by technical infrastructure and then connected across domains via shared databases or analyses. This work has identified technical challenges in deploying smart city infrastructure, including the integration of data across domains. For example, combining data from a traffic monitoring sensor network and an air quality monitoring sensor network. We went into this study with the following research question: how do socio-technical factors influence the design and deployment of smart city systems, and thus the architecture and flow of data within such systems? A socio-technical perspective highlights the interdependent and inextricably linked relationships among the features of any technological object or system and the social norms, rules of use, and participation by a broad range of human stakeholders. Our focus in this study was on large-scale projects that involved sensors and in which a local government entity was a dominant stakeholder. We approached this research question via interviews with professionals involved in the deployment and operation of urban sensor networks in one American city. Our data revealed many of the social and organizational challenges involved in deploying and operating smart city infrastructure. For example, as demonstrated in a quote by participant 11 in our study, combining data across domains also means setting up collaborations between different city departments as well as with private companies. Public Works or the Transportation Department might know what's up on the street, the Parks Department might be in charge of the trees, so it's like there's a lot of different entities that have interest in the public right-of-way, but there's no one owner of it all that can manage it super effectively or efficiently. Meanwhile, we're giving it to the private sector, often for very low costs and sometimes for nothing, to crowd up that space. We focused our investigation on urban sensing projects in Denver, Colorado, a fast-growing city in the Mountain West region of the United States. The majority of projects discussed were explicitly part of the Denver Smart City program. We collected data via semi-structured interviews. Each interview covered the flow of data in specific projects, how those projects related to the broader concept of a smart city, and general comments on the use of data in the participants' work. We prompted all participants to elaborate on both the technical as well as the social and organizational aspects of each project. We systematically recruited 12 participants in order to provide perspectives across a number of sensing projects in the region. Most participants had experience in mid to upper level management positions within local government. Our analytical framework used for the first round of coding of this interview data was adapted from Nafade and colleagues' foundational work discussing the system of systems vision of a smart city. From the interview data, we found that data collection activities involved instances of collecting data from ambient sensors, vehicles, or people's personal devices. Data management involves storing data, primarily in databases that are shared across multiple departments or agencies. Data analysis involved processing data into actionable information via both real-time and long-term analyses and performing predictive modeling. And data impacts involved influencing outcomes by informing the public, actuating infrastructure, or responding to events. Multiple rounds of iterative inductive coding were performed within the data in these phases to identify subcodes and cross-cutting themes. Detailed discussion of our results are provided in the paper. Here we will highlight 4 cross-cutting themes we found and provide illustrative examples. We found each of the phases to display variability in the level of immediacy, level of automation, geographic scope, and ownership. The concept of real-time is core to smart city rhetoric. In systems that are closer to real-time, data is captured from sensors nearly instantaneously at regular short intervals of time, automatically uploaded to databases, and integrated with other data streams. Impacts can also be extremely immediate. For example, when data thresholds cause automatic actuation of infrastructure. However, many of the systems our participants described involve phases that took longer periods of time. For example, when discussing water quality data, participant 3 said, so they want to have all these different real-time data sources out there, that they can start to look at them and see, this is happening and it's causing, the side effect is this. But what I need to be able to do is I need to be able to kind of look backwards to understand what's been going on so that I can think about going forwards. How do we adapt to it? We have close to 20 years worth of data, and we're actually just now getting to the point where we can really start to look at it and understand what's going well. Although automating the stages of data collection, storage, analysis, and impacts was discussed as a goal in urban sensing projects by many participants, we also found that human action or oversight was necessary across all phases, even in mostly automated systems. For example, participant 9 discussed error detection and interpreting readings from flood gauges. If you're used to dealing with the data and you understand it in depth, you probably have a real sense for what's probably wrong. The average person wouldn't know. And I'm going to want some human intervention there, not just gauges thinking they know the answer. Different phases within a project may also operate at different geographic scopes. Data collection may be constrained to city boundaries, or it may be done regionally or nationally. Databases and associated analyses or interventions operate at different scales as well. Broadly, natural boundaries and political boundaries do not align. Many participants discussed how you need a regional view to understand flooding risks, air quality, or water quality within a city. For example, you can see here a picture of the dashboard produced by the Flood Monitoring Network operated by the Mile High Flood District, which operates at a regional rather than a municipal scale. We also observed that within projects, there might be multiple public, private, or academic entities involved across phases. Participant 12 discussed this in one sensing project. You have a lot of parties that need to be involved. So just as an example, this project, so you have starting at the end, you have sensors that measure water quality. Cisco provides the network and the gateways that those sensors will talk on, and then there needs to be some sort of platform that makes sense of all the data that's coming from the sensors through the network to a user. And generally that is a different company developing the dashboard user interface and the IoT integration of all the data to make sense of it. So there's potentially 4 companies involved here, at least. Tensions related to data ownership could arise because of different motivations from public and private institutions, as discussed by participant 1. Because we as a city, we want to have ownership over the data, and vendors, obviously data is powerful, so like then they want to keep ownership of that data. And I think it's something we as a smart cities group need to focus on in terms of data control type of policy, just to ensure that all the data we are getting, like we have ownership over it, and it doesn't reside in someone else's database. Because at any time, they could just cut off access, and then we're just out of luck. In the city that we studied, we did not find an entirely integrated system of systems in which urban sensing systems were combined across domains, nor did we find totally isolated data silos. Instead, we found that different projects had different degrees of cross-domain data integration. In some projects, data was combined across domains into shared databases and analyses. This was seen as desirable and useful by many participants, and most exemplified by the Enterprise Data Management Project in Denver, which is an effort to combine data from different sensor networks into a shared citywide database. For example, participants were eager to combine traffic data and air quality data to study the relationship between traffic patterns and air quality. However, in some cases, data remains siloed between domains. For example, those working on the flood monitoring system did not see any advantage to integrating their data with data from other domains because they wanted to focus on their specific mission of providing flood alerts. Cities around the world are using sensing technologies to try to improve quality of life for residents. We interviewed those working on deploying urban sensor networks to understand how sociotechnical factors influence the flow of data in such systems. We used participants' words to flesh out a rich description of how a smart city vision is realized in a specific city and contrasted their description with the idealized vision of a smart city from the engineering research literature. The examples offered in this work provide clarity within a space plagued by ambiguities and provide a basis for grounded critique of the smart city concept. We provide an emergent analytical framework to support future work in this area, and as discussed in more detail in our paper, our participants' understanding of their smart cities related work as being about collaboration draws attention to this domain as a rich site of study for CSCW researchers. Thank you for your time and interest in our work. For more details, you can read our paper.